morning, class.
Good morning, madam.
Good afternoon. How are you?
Fine.
So, welcome for today's session. Sorry. When is today? Date? When is today? 7.
Yes,
October.
October.
2025, sorry. So, first of all, I need to take a roll call. Gatini, Atieno, Brian Kimball, Wendy, and then Caroline. Thank you. So, on our previous topic, somebody to remind us on what we go through. Yes? Previous lesson. Yes. So we learned about Pythagoras theory. Somebody to remind us about Pythagoras theory. Yes, you know?
Pythagoras theorem is given by a squared plus b squared is equals to c squared.
Correct. Somebody else? Yes? Correct. Okay, what?
We need to reinforce on the answer Atieno's point that Pythagoras theorem was founded by a person called Pythagoras himself, and he said that the sum of the squares of two shorter sides of a right angle triangle is the same as or is equivalent to the sum of the longer side.
Okay,
Came up with
yes. Wendy? That's good. So, in our today's class, we are going to learn on trigonometry ratios of acute angles. Trigonometry ratios of acute angles. So we have the specific SLO, specific learning outcomes. So as a student or as a trainer, you SLO. So by the end of the lesson, the learner, by the end of our session, the learner should be able to, first of all, you should be able to divine cosine, divine cosine, sine, and tangent. And then, after definition, you apply trigonometry ratios. Apply trigonometry ratios to solve acute angles. And finally, use calculators to compute trigonometry values. To compute trigonometry values. So those are our specific learning, our today's specific learning outcomes. So, first of all, we should define or know what is trigonometry, and then trigonometry ratio, and then finally trigonometry ratio of acute angles. Somebody to define for us what is trigonometry? Yes?
Trigonometry is a branch of mathematics that focuses on the relationship between angles and sides of triangles.
That's correct. Somebody else? So we have trigonometry to be a branch of mathematics that deals with relationship between angles and side of triangle. We have example, right angles, triangles. It is widely used in geometry, we have physics, engineering, and even music. So we have the key concepts of trigonometry ratio is using over right angle triangles or using over triangles. So somebody to define for us trigonometry ratios. Trigonometry ratios. Yes.
Trigonometric ratios, these are sine, cosine, and tangents.
Yes, correct. And finally, trigonometry ratios of acute angles. Somebody to define for us.
Acute angles are less than 90 no 90 or less than.
Yes, correct. Somebody else? Having a different answer? So we have trigonometry ratios and the relations of the angles of the right angles to the length of sides. And then we have the trigonometry ratio of acute angles. These are defined only for acute, which are less than 90 in a right angle triangle. So we have something here. We have number 1, 2, then number 3. Examples of a trigonometry ratios or types of trigonometry ratios. So just come and give. Types of trigonometry ratios.
In the first program,
Any.
so like that sine.
Yes. Correct. Somebody else? Number 2, Wendy. Somebody else, number 3. Correct. So we have examples of trigonometry ratios. We have cos, sine, and tan. So before we can define common values for standard angles. Common values for standard angles. We have an angle. Angles. We have sine, cos, and then we have tan theta. We have the first angle to be 0. We have 30 degrees. We have 45 degrees. We have 65 degrees. And then we have 90 degrees. So we are going to divide the common standard values of these angles from 0 to 90 degrees. For example, angle sine of 0 is 0. We have 0. And then cos of 0, 1. We have 1. Tan of 0, 0. So somebody to take us through the second one. Sine of 30, we have cos 30, and then tan of 30. Somebody? Somebody? Come in first. Yes?
Sine 30 a half. A half, like, which is equivalent to 0.5. Then cos 30, 0.9.
Kindly, can you help her?
0.99. Or let me just say.
I think we can use fraction.
Is a square
0.5 you can write half.
square
Yes.
of 3
So it's
A half.
Root 3 over 2.
Root 3.
and 3 over 2.
Assistant.
root 3 over 3.
Root 3 over 3. Over 3.
Is she correct?
Yes.
Can you appreciate that? Thank you. Somebody else to take us through what you like? Yes.
So what is the cos of sine of 45?
Root 2 over 2.
What about cos 45?
Root 2 over 2.
2 over 2. And then tan of 45? 1.
Is she correct?
Yes.
Appreciate her. Thank you. And then we have 65 degrees. Somebody else? Yes? Mr. Kimball? Thank you, assistant.
So the calculators for the sine 65.
Root 3 over 2.
3 cos 65
0.9.
is
In
a
fraction?
fraction.
Fraction?
Cos 65.
So we can leave it as a decimal.
And divide?
0.4226, and then we have tan 65.
2.1445.
2.1445.
And he
About
said
to 90.
90, yeah.
About to 90, I can proceed.
Yeah. Let's continue.
1, 0,
1.
0, and yes, and define.
Is he correct?
Yes.
So let's appreciate him. Thank you. So we can proceed to examples. Using the three examples of trigonometry, ratios of acute angles, sine, we have cos, and tan. So we can use SOHCAHTOA. Sine theta, we have cos theta, and then tan theta. We have sin theta, cos theta, tan theta. Somebody to tell us what is sin theta? Using SOHCAHTOA, yes?
Opposite of hypotenuse.
We have opposite over. And then we have cos theta, Eric.
Adjacent to hypotenuse.
And finally we have tan of theta. Yes?
Opposite of adjacent.
Yeah, we have sin theta to be opposite of hypotenuse. We have cos theta to be adjacent of hypotenuse. And finally tan theta to be opposite over adjacent. So our first example, we have in a right angle, one of the acute angle, that is our theta to be 30 degrees. The hypotenuse is 10 centimeter. Find the length of the opposite and adjacent. We have something like this. So we have been told our theta to be 30, and then the hypotenuse is 10 centimeter. So find the length of opposite. Yeah. So we can use our A and B. We have an angle to be 30 degrees, and then we have one of the sides that is hypotenuse to be 10 centimeter. And then we have been told find the two sides. These are opposite and hypotenuse. First of all, I think we are going to use Okatoa. Already we have hypotenuse. So just we are going to find the value of A and our B. So to get the value of A, we have Okatoa. So to find the value of A, we are going to use, is it sine or cos? Sine. So we have sine, that is equals to opposite over hypotenuse. So sine, that is, our opposite we have to be A over hypotenuse, which is 10 centimeter. So our sine that is, is it 0.5? So cross multiply, we have sine 30 times 10 centimeter is equals to A. So sine 30, which is 0.5 times 10 is equals to A centimeter. Our A is
5.
Our A is 5 centimeter. Correct? So you can proceed to find the value of our B. Our B, we have our theta, which is 30 degrees, and then hypotenuse, we have 10 centimeter. So we are going to use, is it cos? We have cos theta, which is cos 30 is equals to adjacent over hypotenuse. So it will be cos of 30 is equals to our adjacent, which is we denote to be B over hypotenuse, which is 10 centimeter. And then you cross multiply. We have cos 30 degrees multiplied by 10 centimeter is equals to B. So cos that is equals to
3 over 2.
we have root 3 over 2 multiplied by 10 centimeter to give us the value of B.
8.3.
5
Root 3.
5 root,
No. Root 3.
is it 5 root
Yes.
3 in decimals
8.66.
or
8.66.
8.6
60.
0 centimeter.
Yes.
Correct. Have you understood?
Yes.
I hope everyone knows on how to use calculators. Huh? Is there any particular challenge? Huh? Are we okay?
Yes.
Yes. Our second question. In a right angle, the opposite side is 6 centimeter, and then you have the adjacent side to be 8. Find the angle and the hypotenuse. In a right angle, the opposite side is 6 centimeter, and we have the adjacent to be 8. Find the angle. Can you pair us your pen? We have two angles. The opposite side 6 centimeter and adjacent side 8. Find the hypotenuse and give us the angle. Yes. Angle and hypotenuse. What opposite? We have the opposite side to be 6 and then 8. Not opposite. Sorry. we have the adjacent to be 6, and then we have the opposite is 6. So find the hypotenuse and the angle. Yeah, can see most of you in the right chest. Yes. The answer is 7 degrees. Yes, you are correct. Somebody else? Yeah, the hypotenuse to be 10. So I want one from you to volunteer. Somebody to volunteer? Yes.
The side opposite is 8, then adjacent is 6. So we're going to use tan because we have opposite and adjacent. So it will be tan theta is equals to 8 over 6. So tan 8 divided by 6.
Thank you, sister.
8 over 3. 1.3. Then in order to find the theta, it will be tan inverse 1.3.
53.13 degrees.
53.13
degrees.
So here is 53.13. And in order to first to find hypotenuse, since it's a right angle triangle, we will use 8 square plus like this formula 8 square plus b square is equals to 6 square, which is 8 square plus 6 square is equals to 6 square. 8 square 64 plus 36 is equals to 6 square. 64 plus 36 is 100 is equals to 6 square. When we square, C is equals to 10. So our hypotenuse is 10.
Is she correct?
Yes.
Can you appreciate that? So we have 8 to be our opposite, and then we have our adjacent to be 6. And then we have been told to find the value of our theta and the value of our height. So we are going to use tan, which is tan theta. Tan is equal to opposite of our adjacent, which is 8 over 6. So our tan theta is 1.3. To find the angle, we are going to find the tan inverse of 1.3, it will give us 53.13. And then to find the value of hypotenuse, so this one takes us back to Pythagoras theorem, isn't it?
Yes.
A squared plus b squared is equals to c squared. We have our a to be 8, and then our b to be 6. So 8 squared plus 6 squared give us 100. Isn't it? We have 64 and 36, which 64 plus 36 give us 100. And then you find the square root, which will give us 10. We have our final question. We have a triangle as one side, which is 9 centimeters. As two sides, we have 9 centimeters to be adjacent. One of the angle either opposite or adjacent to be 9 centimeters. And then we have our hypotenuse to be 15 centimeters. So find the cos theta. center. Correct. Somebody else? Yes. Correct. So what is the answer?
53.
We have to 53 degrees, isn't it?
Yes.
All of us? Have we have the same answers?
Yes.
Isn't it 53? Somebody with a different answer? So thank you. We have our assignment. So on our assignment, we are going to deal with real life application. We have a ladder. A ladder means against the wall, making a 60 degrees, angle with crown. If a ladder is 10 centimeter, long, how high have the wall does it reach? So that's our assignment. Kindly write the assignment. A ladder lean against a wall making 60 degrees. A 60 degrees angle with crown. If a ladder is 10 centimeter long, how high at the wall does it reach? So this one is our assignment. Before we start our next class, which will be on next week on Monday, we are going to go through this one before we begin our lesson. So thank you. So first of all, before I end up my lesson, I think we can review on our topic, on our session today. So first, we can review. Somebody, what we have learned?
We have learned about trigonometric ratios of acute angles.
Correct,
And realized that an acute angle is less than 90 degrees.
correct. Somebody else?
Of,
What we have?
gain the understanding of how I decide on which route I can use, because I can calculate the line of and decide which I can use using it.
Correct. Somebody else? Yes, Wendy?
There's lambda sine theta equals to opposite of a hypotenuse.
Yeah, thank you. I can see most of us, we have learned something. So, is there any question or clarification? Is there any question? So, yeah, dismiss. That means next week on Monday. Thank you. Thank you. Have a good day.
You too.